In this video, we are going to learn how to factor quadratic expressions when the leading coefficient is not 1 or -1. So, to review something we talked about in the previous lesson on factoring quadratic expressions, to factor ax squared plus bx plus c, if we think of FOIL in reverse, we're looking for our first terms to give us ax squared, our outer and inner terms to give us bx, and our last term to give us c. So now, what is 2x squared plus 11x plus 12 in factored form? So following this mantra up here, I need to find two first terms that multiply to give me ax squared, which is 2x squared. So it can either be 2 and x squared or 2x and x. And I'm going to give the hint here that it's 2x and x, because if it was 2 and x squared, that would mess up my outer and inner because those would no longer add to bx. So I'm going to have to go with 2x and x. Now, to find the outer and inner, I need to pick some last terms, but those have to multiply to 12. We have a bit more complicated of a problem here because now, depending on where we put those factors, they'll be multiplied by two different x factors, which is 2x and x. So I'd start thinking now, all right, if I have 2x and x, one way to make 12 is to use 1 and 2. But if I do my outer and inner there, 1 and 12. And if I do my outer and inner, I would have 24x plus x with my inner, which gives me 25x. So that doesn't work. But if I take that same scenario, 2x and x, but now I put the 12 first, I put plus 12 and then plus 1, I will have 2x as my outer and 12x as my inner, and that gives me 14x. So even though I'm using positive 1 and positive 12, depending on which x or 2x I put it with, it changes my inner term. So I have to try in both directions every time. So now I have 2x and I have x. Another way to make 12 is 2 and 6. So I can do 2x plus 2 and x plus 6, which if I do my outer term, that gives me 12x plus 2x, which is 14x, which isn't right. I need 11x. And I can do 2x plus 6 first, and then plus 2. And the outer would give me 4x, and my inner would give me 6x, which is just one off. I need it to be 11, but I got 10x. And then I could still try 3 and 4. So I have 2x. And I hope I get it here, because otherwise I'm trying these all as -1 and -12. But I have a feeling if I make them both negative, these will both be negative. Give me -25, which I want a positive number here. So now I have 2x. I could do it plus 4 and then plus 3, which will give me outer as 6x, inner as 4x, which is 10x, which is still one off, but I still can try 2x plus 3 and x plus 4, which when I try this one out, my outer gives me 8x and my inner gives me 3x, which is 11x. Finally, I got what I need. So when this factors, it'll be 2x plus 3 times x plus 4. And just to double check that this is correct, I'll distribute, so I'll have x times 2x plus 3 plus 4 times 2x plus 3. Distribute the x, I get 2x squared plus 3x plus 8x plus 12, giving me 2x squared plus 11x plus 12, which is what I wanted to factor. Now let's break down what just happened in all the parts. So again, we have our a term, our b term or bx term, and RC term. If I go back one step, you can compare them. Because now the 11x was broken up into 3x and 8x. And you have 2x. So now, the two numbers we should probably look for is we want them to still add to 11, but 3 times 8 is not 12. But if we look at A times C, what's 2 times 12? Well, that's 24, and 3 times 8 is 24. So there's our pattern. This step right here in the middle, finding these two numbers is the key to factoring these types of expressions. So now, when factoring ax squared plus bx plus c, I'm trying to find two numbers such that their sum is still b, but their product is a times c instead. So let's give that a shot. So going up here, I'm looking at a times c, which is usually the outer factors, outer terms. So a times c would be 4 times negative 3, which gives me negative 12. So I need two numbers that multiply to negative 12, but then add to negative 4. So going through, it has to add to a negative number, so now I want the bigger number to be negative. So if I thought of 1 and negative 12, they would add together to give me negative 11, which isn't quite right. I can also do 2 and negative 6. Those add together to give me a negative 4. Now, instead of jumping straight to the answer here, I'm going to try to actually work this backwards until I eventually get to my answer. Because if I look at this example down here, going backwards, from here to here, if I looked at just the left two terms, I'm factoring out an x. And my right two terms, I'm factoring out the common factor of 4. And after I factor that out, I see that this entire expression had a common factor of 2x plus 3. And when I factor that out, I was left with x plus 4. That's the way that you can really factor these quickly instead of having to guess so many times until you get it right. So we're going to use 2 and negative 6, but this time we're going to think of it as 4x squared. But instead of minus 4x, we're going to think of it as plus 2x, that's that positive 2, minus 6x, there's that negative 6, and then that minus 3. And now going backwards, I'm going to group them together. I'm going to think of this as one group and the second two terms as the second group, and I'm going to factor out a greatest common factor in each of those groups. So looking at my first group, its greatest common factor is 2 and x, because 4 and 2 are both divisible by 2, and they both have an x as a factor. So I can factor out a 2x. And when I factor that out, I'll be left with 2x, and then 2x divided by 2x is 1. So again, don't be careful not to make that 0. You're still dividing by that 2x. Now in my second group, they're both negative, so I should definitely factor out a negative value. And they both have 3 in common, so I can factor out a negative 3. When doing so, I'll be left with negative 6x divided by negative 3, which is 2x, and negative 3 divided by negative 3, which is 1. Now, to be sure if this actually factors, these two factors I have here in blue should be the same, because now I can see that amongst both of these terms, the 2x times 2x plus 1 and the negative 3 times 2x plus 1, 2x plus 1 is the greatest common factor, and I can factor out 2x plus 1. And when I do so, I'll be left with 2x minus 3. Now, if I were to try to do this problem the same way I did it over here, it might take me longer, the same amount of time, but I'll have to consider 2x and 2x makes 4x squared, but also x and 4x makes 4x squared. So there'll be a lot of possibilities for me to go through until hopefully I land on this correct solution. Now let's try this again with the next problem. Here we have our a times c, which is the outer two numbers, 4 times 3, which is 12. So they have to multiply to give me 12, the two numbers I'm looking for, and then add together to give me 7. So the way to make 12 is 1 and 12. And again, I want them both to be positive, so I end up with a positive number, which is 13, which isn't right. Well, I can also use 2 and 6, but they add together to give me 8, which is too big. And there's also 3 and 4, which gives me 7. So excellent. Now I can use 3x and 4x for my middle term instead of 7x. So I'll have 4x squared plus 3x plus 4x, with that 3 and 4 I'm using there, and then plus 3. And now I'll do the same thing I did the previous problem. I'll group my first two terms together and my last two terms together. Now the first group has an x in common. That's its greatest common factor. And when I factor that out, I'll be left with 4x plus 3. Now the second group doesn't seem to have any factor in common. So I'll just put a plus, but you can think of it as an understood 1 in front of this group. So it'll just be plus 4x plus 3. But there is an understood 1 in front of the parentheses. So when I factor out the greatest common factor here, it's 4x plus 3. And when I divide each term by 4x plus 3, I'll be left with x and then plus 1. Now for the last example, I have 2x squared minus 7x plus 6. A times c will be 12 again. And they need to add together to give me negative 7. So in this case, I want both my factors to be negative. So if I use negative 1 and negative 12, that adds together to give me negative 13. If I use negative 2 and negative 6, they add together to give me negative 8. So these aren't working so far, but lastly I have negative 3 and negative 4, which they add together to give me negative 7. So that is the proper number I'm looking for. I want them to add to negative 7. So now I can rewrite this quadratic expression as 2x squared minus 3x minus 4x plus 6. And then make sure you're doing that right. You can check it with every single one of these so far. If I were to combine these back together, it should bring me back to negative 7x. Even up here, you would see that same thing happen. I'm just splitting the middle term into two terms. And now I'll group. So the first two terms and the second two terms. And the greatest common factor in my first group is x. When I factor that out, I'll be left with 2x squared. Not 2x squared, 2x minus 3. And in my second group, they have a 2 in common. So I can factor out a 2. And I'll be left with negative 2x plus 3. Now that's an issue because now these aren't matching, but they're very close. In fact, these terms are just opposite of these terms. So if I factor out a negative from inside of this parentheses, I should have 2x minus 3. But what happens to the positive 2 on the outside, that now becomes a negative 2. But on the inside, I'll divide everything by a negative 1, give me 2x minus 3. And now we can see our greatest common factor is 2x minus 3. And when we factor that out, dividing each of these terms by 2x minus 3, we're left with x minus 2. And that would be 2x minus 3 times x minus 2 is how you factor 2x squared minus 7x plus 6. Now, the step I'm putting out here on the right for all these problems, Eventually, you can start to do that mental math in your head and then jump to this next step. This is a great visual to see what you should be thinking about as you go to factor quadratic expressions. And that is how you factor quadratic expressions when the leading coefficient is neither 1 nor -1.